Usually when we talk about a medical diagnosis, there's this expectation of precision. You break your arm, the x-ray shows a jagged white line, and the doctor just points at it.
Right. They say, there it is. It's very binary.
Exactly. It's either broken or it's not. We like things to be visible and, well, easily categorized.
Yeah, but you step into the world of poultry science, and that x-ray machine is completely useless.
Totally useless. We are looking at a diagnostic landscape that is just very murky today. We're hunting an invisible, indestructible enemy.
It really is a major threat in the global poultry industry. It's called CAV.
Right, and that stands for Chicken Anemia Virus.
It's the absolute definition of a silent killer. I mean, the biology of this virus is terrifying.
It is. And the way it forces these massive pharmaceutical companies to fight each other, well, it's just a fascinating story.
But before we jump into the hard science, we really want to speak directly to you, our listener.
Yes, we have a very special mission for this deep dive. We know you are practicing your English shadowing today.
Exactly. You are here to master professional poultry science vocabulary.
Because of that, we are adjusting our style a bit. We're going to keep our sentences short. We will speak very clearly.
And we will leave brief, natural pauses after important ideas. This gives you time to absorb the information.
Right. It gives you time to practice the terms out loud right along with us.
So looking at the sources today, we have comprehensive global reports, competitor intelligence maps, and detailed veterinary manuals.
Yeah, we're going to explore how this tiny virus survives extreme conditions. We'll see how it silently steals farm profits.
And we'll learn why the global vaccine market is locked in such a fierce battle over it.
Because, as we always say, the biology of the virus completely dictates the business strategies.
You really cannot understand the money until you understand the microbe.
So true. So let's meet the microbe. Let's look at the biology of CAV. I want to start with its physical size. Just how small is this enemy?
It is incredibly tiny. CAV measures about 25 nanometers in diameter.
Wow, 25 nanometers.
Yeah, to put that in perspective, it is literally one of the smallest viruses known to infect animals.
25 nanometers is almost impossible to imagine.
It truly is. Biologically, it's a circular, single-stranded DNA virus. It belongs to a genus of viruses called gyrovirus.
Okay, gyrovirus.
Right. But here is the most important structural detail. It is a non-enveloped virus.
Now, what does non-enveloped mean? Like, why does that matter to a farmer?
Well, a viral envelope is basically a layer of fat. It's a lipid layer. Many famous viruses have this fat layer.
Okay, so it's a protective fat coating?
Actually, it's a vulnerability. When you wash your hands with soap, the soap breaks down the fat.
Oh, I see.
Yeah, the virus falls apart. It dies easily.
Okay, so soap destroys the lipid envelope.
Yes. But CAV has no lipid envelope. It has no fat layer for you to break down.
Meaning it's tough.
Because it lacks this envelope, it's incredibly tough. It is basically an armored tank.
When you say tough, how tough do you mean?
I mean, it can survive in a highly acidic environment. It can handle a pH of 3.0 without breaking down. And it can also survive extreme heat. It can withstand temperatures up to 80 degrees Celsius.
Which is what, about 176 degrees Fahrenheit?
Exactly. It can survive that boiling heat for a full 30 minutes.
That is like a boiling acid bath. So if it's this tough, standard cleaning must be completely useless.
It really is.
If I wash my barn with heavy bleach, does the virus die?
No. And that is a very hard truth for farmers to accept. Standard biosecurity is completely hopeless against CAV.
So you can't just clean it away.
You really can't. The virus will live in the deep litter of a barn forever. It just laughs at standard industrial disinfectants.
So the virus is hiding in the dirt. It's completely safe. It's just waiting for the chickens.
Exactly.
How does it actually hurt the bird once it gets inside?
Well, the virus produces a very unique protein. This protein is called a poptin.
Poptin.
Or sometimes it's called VP3. And a poptin has one specific deadly job. It triggers a process called apoptosis in the host cells.
Apoptosis. That means programmed cell death, right?
Exactly. The virus literally forces the chicken cells to commit suicide.
That's brutal.
And it doesn't just attack any cell. It is very specific.
Which cells does it target?
First, it targets T cells. T cells are found in the chicken's thymus.
And the thymus is vital for the immune system.
Yes, it's the core of it. The virus forces these T cells to die.
If the T cells die, well, the chicken has no defense.
Exactly. And this brings us to our first vocabulary word for you, the listener. This total collapse of their defenses is called immunosuppression.
Listen closely and practice shadowing this term, immunosuppression.
Because of immunosuppression, a simple cold can sweep through the bar and kill the flock.
So the immune system is gone.
Yeah.
But you mentioned a second target. What else does the apoptosin protein attack?
It also targets the bone marrow. Inside the bone marrow, there are specific blood-forming cells.
Okay, blood-forming cells.
They're called hemocytoblasts. These cells manufacture red blood cells. The virus forces these factory cells to commit suicide too.
So if the factory is dead, the bird just stops making red blood cells.
Yes. The bird's blood becomes thin and watery.
And this leads to our second vocabulary word. This severe lack of red blood cells is called aplastic anemia.
Get ready to shadow this one. Aplastic anemia.
The vet diagnosed aplastic anemia when she saw the bird's pale comb and yellow bone marrow.
Wait, let me emphasize that visual. Yellow bone marrow.
That sounds unnatural.
It is. That's a classic diagnostic sign. Normally, healthy bone marrow is dark red because it's full of blood.
Right.
But because the virus destroys the blood-forming cells, the marrow turns into pale yellow fat.
Wow.
A veterinarian will split the chicken's thigh bone open. If the inside is yellow, well, CAV is highly suspected.
That is a brutal visual. So we have an indestructible virus in the dirt. It causes immunosuppression. It causes aplastic anemia.
Right.
How exactly does it move from one bird to another?
That takes us to the routes of invasion. CAV is highly contagious.
We know it lives in the deep litter on the floor.
Yeah, but it also lives on feeding equipment. It can even survive on the gloves of workers who perform artificial insemination.
So it just spreads through basic daily contact.
Yes. It spreads directly from bird to bird. It spreads through infected feces. It spreads through dander, which is feather dust floating in the air.
And that sideways spread across the flock is our third vocabulary word. It's called horizontal transmission.
Let's practice saying it together. Horizontal transmission.
Horizontal transmission happened when the healthy chickens pecked at infected manure.
Now, horizontal transmission is dangerous. It ruins a barn. But there's another route.
And this second route is far more devastating, right? This involves the mother hen.
Exactly. If a mother hen catches the virus while she is actively laying eggs, a biological disaster occurs.
Tell us what happens.
The virus enters her bloodstream. Then it passes directly into the embryo of the egg she's forming.
So the egg looks completely normal on the outside.
Yes, it looks perfect. But inside, the chick is developing with the virus already in its body.
That's terrifying.
When the chick hatches, it is viremic. That means its tiny bloodstream is already full of the virus.
And this downward spread from parent to child is our fourth vocabulary word. This is called vertical transmission.
Shadow this phrase with me. Vertical transmission.
To stop vertical transmission, the farmer must make sure the mother hens are healthy before they lay eggs.
Vertical transmission is the ultimate nightmare for a commercial hatchery.
It sounds like a Trojan horse. I mean, the farmer thinks they're buying clean, healthy eggs.
Right.
But the enemy is already built right inside the shell.
That is a perfect analogy. Imagine thousands of chicks hatching in a massive incubator on the exact same day.
Okay.
And let's say just a few of them were infected via vertical transmission.
What do those few infected chicks do?
They act as biological bombs. The moment they hatch, they start shedding the virus.
They're shedding it everywhere.
Yeah, they shed it in their feces, they shed it in their feather dust.
And that triggers massive horizontal transmission.
Exactly. The vertically infected chicks spread the virus horizontally to all the healthy chicks around them.
So it multiplies instantly.
They infect the whole incubator, they infect the transport trucks. By the time the chicks arrive at the farm, the entire flock is doomed.
That is just terrifying. So the obvious signs of CAV are sick, dying baby chicks. But let's look at the older birds.
Good idea.
I want to talk about a major rumor in the poultry industry.
You're talking about the age resistance myth. This is a crucial topic to clarify for anyone learning poultry science.
Yes. So let's look at the timeline first. Chicks that are under 3 weeks old show severe clinical signs.
Right, their combs turn very pale, they have bleeding under their skin.
What is the actual mortality rate for these babies?
It is grim. The mortality rate is normally 10 to 20%. But if there are secondary bacterial complications, mortality can spike up to 60%.
60%. That is a massive financial loss.
It is.
But farmers often claim that older birds are safe. They call it age resistance.
Yeah,
They believe that if a bird reaches 4 rits of age, it basically becomes completely immune to CAV.
And that is a dangerous market myth. They think the danger has passed, but they are wrong.
So older birds are not immune.
Well, the truth is nuanced. Older birds do develop a resistance to the acute, deadly anemia.
Okay.
Their immune systems are mature enough to stop the massive blood loss. so they do not drop dead with pale combs.
So if they don't drop dead, what's the actual problem?
The problem is the silent damage. The virus still invades their body. It still enters the thymus.
Where it destroys the T cells.
Exactly. You look at the older bird and it looks fine. It's walking around. It's eating. But inside, its immune system is deeply compromised.
And this hidden sickness brings us to our fifth vocabulary word. It's called a subclinical infection.
Remember this concept and shadow it. Subclinical infection.
The farmer didn't know the birds were sick because a subclinical infection has no obvious symptoms.
This subclinical infection is a silent thief. Because the immune system is damaged, other medical treatments just fail.
Give me an example of a treatment failing.
Let's say the farmer gives a routine vaccine for Marek's disease, or they vaccinate for Gumboro disease.
Very common practices.
Right. Those vaccines need healthy T cells to work properly. They need the immune system to respond and learn.
But CAV already destroyed the T cells.
Exactly. So the other vaccines fail. The farmer spent all this money on Marek's vaccines, but the flock is still unprotected.
That's devastating.
And the door is also left wide open for secondary bacterial infections like E. coli.
So what does this all mean for the farmer's wallet? We know dead chicks cost money. But how much does this silent thief steal from the older birds?
The economic loss is staggering. The sources highlight landmark studies by a researcher named McNulty.
Okay, McNulty.
His data shows that this hidden subclinical infection reduces net farm income by 10% to 13% per 1,000 birds.
A 13% drop in net income is huge. I mean, farming runs on very tight margins.
Very tight.
How exactly are they losing that specific money if the birds aren't dying?
A major factor is lost feeding efficiency. The sick birds just cannot digest food properly. They eat the grain, but they do not grow muscles effectively.
And this efficiency metric is our sixth vocabulary word. It's called the feed conversion ratio.
Let's repeat that metric together. Feed conversion ratio.
Because the chickens had a poor feed conversion ratio, the farm spent too much money on feed.
It's a critical metric in the industry. You want the feed conversion ratio, or FCR, to be as low as possible.
Meaning a small amount of feed creates a large amount of meat.
Yes. Subclinical CAV worsens this ratio by about 2% across the whole flock.
I want to use an analogy here for our listener. A subclinical infection is kind of like a slow, invisible leak in your car's gas tank.
Oh, I like that.
You don't see a dramatic explosion on the highway. There are no flames. But you are constantly losing money every time you buy gas.
It perfectly describes the silent economic drain. The fuel is just dripping away.
Right.
And because you cannot see the leak easily, you need special tools to find it. You cannot just look at the flock to diagnose a subclinical infection.
So how do you find the invisible leak?
Veterinarians have to use advanced molecular diagnostics. They use a test called qPCR testing.
How does qPCR work in this case?
The vet takes tissue samples from the bird's spleen or thymus. The qPCR test amplifies the genetic material.
Looking for the virus.
Yes. It searches for the specific viral DNA of CAV. That is the only way to mathematically prove the silent thief is present in those older birds.
So we have covered a lot of dark territory. We can't kill the virus with bleach. It silently robs older birds. It brutally kills young chicks.
It's a tough situation.
So how do we defend the flock?
We must build the ultimate shield, but the global strategy is counterintuitive.
How so?
It surprises many people outside the industry, but we do not vaccinate the meat chickens.
The meat chickens are called broilers. Why wouldn't we vaccinate the broilers directly? I mean, they're the ones going to market.
There are two major reasons. First, a broiler chicken has a very short lifespan. It only lives for 35 to 45 days before it is processed for meat.
Wow, that is very fast.
Yes. If we inject a vaccine into a day-old broiler chick, the bird's body needs weeks to build strong immunity.
Right. Vaccines take time.
By the time the immunity is finally ready, the bird's life is already over. It is a total waste of money and labor.
That makes sense. What is the second reason?
The second reason is basic safety. The CAV vaccines we use are live viruses.
Oh, I see where this is going.
Yeah, if we give a live virus vaccine to a very young, vulnerable broiler chick, we might accidentally cause the exact disease we are trying to prevent. Their immune systems are too weak to handle it.
So, if we cannot vaccinate the babies, what is the strategy?
The entire global strategy relies completely on the mothers. We vaccinate the mother hens. In the industry, we call them breeder hens.
When do we vaccinate them?
We vaccinate them long before they start laying eggs, usually between 8 to 12 weeks of age.
Walk me through the biology. What does vaccinating the mother do for the baby chick?
It does absolutely everything. When the mother hen is vaccinated at 10 weeks old, her immune system fights the safe vaccine virus.
Okay.
Her body builds massive amounts of protective antibodies.
So she builds her own armor.
Yes. Then, months later, she starts forming eggs. As the egg yolk develops inside her, she packs those protective antibodies directly into the yolk.
So the egg yolk is not just food, it's actually medicine.
Exactly. When the baby chick hatches, it absorbs the rest of that yolk into its abdomen.
Pulling it all inside.
It pulls the mother's antibodies directly into its own bloodstream. The chick is born wearing an armor of antibodies.
And this armor protects the chick during its most vulnerable time, which is those first 2 to 4 weeks of life.
Yes. By the time the maternal armor wears off, the chick's own immune system is mature enough to survive the virus in the environment.
And these protective proteins are our 7th vocabulary word. They're called maternally derived antibodies.
Let's practice saying the full term, maternally derived antibodies.
The baby chick survived the virus because they had high levels of maternally derived antibodies.
To completely block vertical transmission, we need a massive amount of these antibodies. The sources mention a specific laboratory measurement for this.
What is the target number they need to hit?
The breeder flock must have an average neutralizing antibody titer higher than 8 log 2.
8 log 2.
Right. If the titer is that high, the wild virus cannot survive in the mother's blood. It cannot pass into the eggs. The chicks are completely safe.
Now, I have a pushback question here.
Go for it.
Vaccines cost a lot of money. Farm labor costs money. Why not just let the mother hens catch the wild virus naturally?
What do you mean by naturally exactly?
Like, can't the farmer just take some infected dirt from an old barn and throw it into the breeder barn when the hens are young? Let them get sick, recover, and build natural immunity. Isn't that cheaper?
I must push back very strongly on that idea. The veterinary consensus is crystal clear on this. Natural exposure is a historical practice.
So they used to do it.
Yes, some old-school farmers used to do exactly what you described. But today, it is considered an epidemiological disaster.
Why is it a disaster? If they catch the wild virus, they build the same antibodies, right?
The antibodies are the same, yes, but the timing is sloppy. Natural exposure is not uniform.
I see.
If you throw infected manure into a massive barn containing 10,000 birds, not every bird gets sick at the exact same time.
The exposure is uneven.
Exactly. Some hens will catch it on day 1, some might catch it on day 20. But some hens might not catch the virus at all during that young exposure window.
So there are missed hens in the flock.
Yes. Those missed hens remain completely vulnerable. Months go by. Those missed hens become adults and start laying eggs.
And if the wild virus finally reaches them then?
While they are actively producing eggs, it is catastrophic.
Because they have no antibodies.
Right. They experience a massive virus spike in their blood. They pass the live, deadly virus directly into the eggs they are laying that week.
And that triggers the vertical transmission nightmare at the hatchery we talked about.
Precisely. The hatchery will be flooded with viremic biological bomb chicks. The only way to guarantee every single mother hen has high antibodies at the exact same time is to use manufactured vaccines in a strictly controlled program.
Okay, that logic is airtight. We absolutely must use manufactured vaccines.
Without a doubt.
But this leads us to a very strange scientific mystery. I mean, in 2026, you would think we would just use a state-of-the-art mRNA or recombinant vaccine to fix this quickly.
You would think so.
Why is the vaccine technology for CAV seemingly stuck in the 1990s?
That's a brilliant question. If you look at modern poultry vaccines for other diseases, they use incredible space-age technology. They use something called recombinant vector technology.
What exactly is recombinant vector technology?
It means scientists take a harmless, safe virus. For example, they often use a turkey herpes virus.
Okay.
They use it as a delivery vehicle. They paste tiny pieces of DNA from a dangerous virus onto the harmless vehicle.
Oh, it's like putting a scary mask on a harmless robot.
Exactly. The immune system sees the scary mask, builds defenses, but the robot cannot actually hurt the chicken.
Brilliant.
Huge pharmaceutical companies like Boehringer Ingelheim make billions of dollars with recombinant vaccines like Vaxitech. They grow them in massive laboratory vats of chicken embryo cells.
But the sources say Boehringer Ingelheim, Zoetis, and Hipra have no commercial CAV vaccine. Why aren't these giant companies making one?
Because of the unique biology of CAV. Do you remember this specific protein we talked about earlier? The one the virus produces?
Yes, apoptin, PP3.
Yeah.
The protein that forces the cells to commit suicide.
Exactly. If scientists try to put the CAV genes, specifically the apoptogen gene, into a high-tech lab-grown vector virus, it fails immediately.
Why does it fail?
Think about the manufacturing process. The scientists grow the vector virus in massive vats of chicken embryo cells.
Right.
As soon as the new vector virus starts producing the apoptogen protein in the laboratory, the apoptogen does its job. It instantly kills all the chicken embryo cells in the vat.
Wait, really? The virus's own deadly weapon prevents scientists from mass-producing a high-tech vaccine against it.
Yes. It is a biological paradox. It is currently impossible to mass-produce recombinant CAV vaccines using standard cell cultures.
Because the apoptogen destroys the factory before the vaccine can be bottled. That is unbelievable. So if modern tech fails, what do we use instead?
The industry is forced to use old-school traditional vaccines. These vaccines cannot be grown in generic cell vats. They must be grown very carefully inside actual eggs.
Real eggs.
Yes, they use specific pathogen-free eggs known as SPF eggs.
And this older, weakened formula brings us to our 8th vocabulary word. It's called a live attenuated vaccine.
Please shadow this term, live attenuated vaccine.
The vet stored the live attenuated vaccine in the fridge to keep the weakened virus alive.
Growing live viruses in SPF eggs is slow, it is expensive, it is a technology from decades ago.
And because the technology is stuck in the past, the global market is basically an oligopoly.
Yes, only 3 giant companies control the CAV vaccine market. They are Elanco, MSD, and
I'm
Civa.
playing with those 3.
They dominate because they mastered these old-school egg-based techniques decades ago. New tech companies cannot enter the market because they rely on cell vats, which, as we know, apoptogen destroys.
So we have 3 giants, Elanco, MSD, and Ceva. How do they compete against each other if they all use older tech?
Well, the big debate is not about new technology. The debate is about delivery routes and viral strains.
What do you mean by delivery routes?
Basically, how do you get the live attenuated vaccine into the chicken? And which weakened strain of the virus creates the best antibodies?
Let's break down the competitors one by one. Who is first?
Let's look at MSD. Their product is called Nobilis CAVP4. It uses a viral strain called 26P4.
Okay, 26P4.
This vaccine requires individual injection.
Like a shot at the doctor's office.
Yes. A farm worker must physically catch every single bird. They inject the vaccine with a needle into the breast muscle or under the skin.
That sounds incredibly slow. You have to catch 100,000 birds by hand.
It is slow, but MSD claims this method guarantees absolute mechanical precision. They argue every bird gets the exact right dose.
Mathematically, that makes sense. What is the next approach?
Next is Ceva. Their product is called Circumune. It uses a different strain called Delrose.
Delrose. And how is it delivered?
They use a delivery method called wing web stabbing.
Wing web stabbing. That sounds intense.
It is exactly what it sounds like. A worker takes a special applicator needle with 2 tiny prongs. They dip it in the vaccine vial.
Okay.
Then they stab it directly through the thin, translucent skin of the chicken's wing web.
Why stab the wing web?
It is very visual. A few days later, a small bump or scar appears on the wing.
Oh, like proof.
Exactly.
Yeah,
The farmer can visually check the wings to prove the vaccination actually worked.
But again, that requires catching every single bird by hand. It sounds so stressful for the animals.
It is.
What is the third company doing?
The third is Elanco. Their product is Avipro-Thymovac. It uses a very famous viral strain called CUX1.
CUS1.
And Elanco takes a completely different delivery approach. This vaccine is delivered via the farm's drinking water.
And this flock-wide treatment is our 9th vocabulary word. It's called mass vaccination.
Let's practice the term together. Mass vaccination.
Mass vaccination saves time and reduces stress for the birds.
Elanco argues that letting the birds drink the vaccine naturally is the best way. No catching, no needles, no stress.
So we have injection, wing stabbing, and drinking water.
Yeah.
But how do we know which method actually creates the strongest maternal shield?
Well, the sources cite a major independent field study from 2016. It was conducted in Thailand by a leading researcher named Chansiri Pornchai.
And they tested these.
Yes, they tested these exact commercial vaccines head-to-head on real working farms.
What were the results?
The results were shocking. Let's look at the antibodies in the blood.
Before you give the numbers, let's introduce our final vocabulary term. This successful change in the blood, proving the antibodies are there, is called seroconversion.
Listen to the pronunciation and shadow it. Seroconversion.
The farm manager was happy to see 100% seroconversion, meaning every bird was now protected.
Exactly. Seroconversion is the proof of success. The Thailand study measured the seroconversion titers of the different methods.
Let's hear the data.
The water vaccine, Elanco's CUX-1 strain, created a massive average antibody titer of 3,993.
Okay, 3,993.
The injection vaccine, MSD's 26P4 strain, only created a titer of 1,650.
Wait, really? The water method was more than twice as powerful as the needle injection?
Yes. Gut absorption of the CUX-1 strain triggered a much stronger immune response than muscle absorption of the 26P4 strain.
But what about the mechanical precision? MSD claimed that using a needle guarantees every single bird gets a perfect uniform dose.
The field data completely destroyed that claim. The researchers measured flock uniformity. They looked at the variance percentage.
And variance means?
A low variance means the flock is uniform and safe. Every bird has a similar level of armor.
What was the variance for Elanco's water method?
The water method was highly uniform. It only had a 19% variance across the flock.
And the injection method?
The injection method had a terrible flock uniformity of 60% variance.
Wow. Why did the needle fail so badly in uniformity? If you use a syringe, shouldn't it be mathematically perfect?
In a sterile laboratory, yes. On a massive, chaotic farm, no.
The real world.
Think about the human element. Workers get tired. Catching thousands of birds causes severe physical stress to the animals. The birds panic. They struggle.
So mistakes happen.
Yes. The human error of injecting a moving, panicking bird leads to terrible uniformity. Sometimes the needle goes in too deep. Sometimes the vaccine just squirts onto the feathers.
That makes perfect sense. Mass vaccination through water is calm. The birds are relaxed. They walk up and drink naturally.
Yes. There's no physical stress, and stress actually lowers immune response.
I have to push back here, though. I'm thinking about the farm's plumbing. What about the risks of water vaccination?
What risks are you thinking of?
If I put a live, fragile virus into the drinking water system of a huge barn, won't the chemicals in the water kill the vaccine before the chicken even drinks it?
That is an excellent, critical question. You've identified the Achilles heel of water vaccines.
Farm water has chlorine in it, right?
Yes. It has chlorine to kill bacteria. It also has heavy metals from old pipes. It has detergent residues.
Which sounds deadly to a live vaccine.
The live attenuated virus is incredibly sensitive to all of these things. If a farmer just dumps the expensive vaccine into the raw tap water, the virus dies instantly. The entire vaccination program fails.
So how does Elanco's water method actually succeed?
Farmers must follow a strict chemical protocol. They must use a water stabilizer. The traditional standard practice is to use skim milk powder.
Skim milk powder. Like from a grocery store or baking aisle.
Exactly like that. Or specialized agricultural stabilizers that use the exact same proteins. The farmer mixes skim milk powder into the main water tank exactly 10 minutes before adding the live vaccine.
How does milk protect a virus?
It is brilliant chemistry. Milk contains high levels of casein proteins.
Casein proteins.
Yes. These casein proteins act like microscopic sponges. They chemically bind to the chlorine ions. They bind to the heavy metals.
So the milk neutralizes the toxins in the water.
Yes. The casein proteins sacrifice themselves. They physically block the chlorine from touching the delicate viral wall of the vaccine.
Wow.
They create a safe microscopic bubble around the virus.
That is fascinating.
This chemical bubble allows the live virus to travel safely down hundreds of feet of plastic pipes, enter the chicken's beak, and reach the stomach alive.
So if a farmer skips the milk powder because they are in a hurry, what happens?
The chlorine rips the virus apart. The mass vaccination fails. The mother hens produce no antibodies.
Leading to a disaster.
Months later, the hatchery experiences catastrophic vertical transmission.
All because they forgot the milk powder.
Exactly.
But if they do it right, Elanco's product is very successful. The sources mention a specific legal claim Elanco holds.
Yes. In the United Kingdom, the Veterinary Medicines Directorate, or VMD, tightly regulates what companies can legally claim on their labels.
And Elanco has a unique claim.
They do. Elanco holds a unique, legally verified claim for Avipro Thymovac.
What do they guarantee?
They legally guarantee that if the mother hen is vaccinated correctly through the water, her immune system will provide maternal protection for her chicks for up to 51 weeks after she was vaccinated.
51 weeks? That covers almost her entire productive life as a laying hen.
Precisely. A breeder hen usually produces eggs for about a year.
Right.
This long-lasting titer provides immense financial security for the farmer. They know the chicks hatched at the very end of the mother's life will still have strong maternally derived antibodies.
We have built a perfect shield.
Right.
We understand the virus. We understand the water chemistry. The mother hens are protected for 51 weeks.
Yes, it sounds great.
But before we wrap up, I want to talk about the future. Is this shield going to hold forever?
That brings us to a very provocative and alarming update from the research community. The battle against CAV is definitely not over.
Why? What is changing out there?
To understand the threat, we have to look at serotypes. Right now, the entire global vaccine strategy relies 100% on a single global serotype of this virus.
Can you explain what a serotype is?
Think of a serotype as the specific 3D shape of the virus. The immune system is like a lock and key.
Okay, lock and key.
The mother hen's antibodies are the keys. They are perfectly shaped to fit the 3D locks on the surface of the CAV virus.
So our current vaccines teach the mother hen to make one specific key.
Exactly. Our old-school egg-grown vaccines assume the virus always looks exactly the same to the immune system. We assume the lock never changes shape.
The viruses mutate, don't they?
Yes, they do. And recent genomic research emerging from Asia shows highly virulent new genetic variations appearing in wild flocks.
What are these new variations called?
Researchers have identified several, but one of the most concerning is called genotype V.
Genotype V. How is it different from the classic virus we've been talking about?
It has mutations in its genetic code. These genetic changes cause physical changes on the surface of the virus.
Oh, I see.
The 3D shape of the lock is changing.
If the lock changes shape, the old keys won't fit.
That is the ultimate fear. If this tiny, indestructible virus mutates just enough to change its external structure, it might completely evade the antibodies we are creating.
So the mother hen packs her eggs full of antibodies. But antibodies are outdated. They are keys to a lock that just no longer exists.
Exactly. If genotype V spreads globally and it evades our current antibody shield, the results would be devastating.
The wild virus would bypass the maternal armor.
Yes, it would infect the chicks vertically all over again.
And we just discussed why we can't quickly invent a new high-tech vaccine for a new variant.
Right, the technology trap. Because Apoptin destroys the cell vats, we can't just spin up an mRNA vaccine in a month like we did for other diseases.
We're stuck.
We would have to start the slow, painstaking process of isolating the new genotype V, weakening it, and growing it in SPF eggs all over again. It would take years.
So the industry is racing against viral evolution, but running with weights on their ankles.
That is a perfect summary. The lingering question for the global agricultural industry is this. Will our current live vaccines still provide enough cross-protection to defend the next generation of the world's food supply?
Wow.
Or is the silent thief learning a new way to break in?
That is a chilling thought to end on. Nature just never stops adapting. We have covered a massive amount of technical ground today. I want to congratulate you, our listener, for practicing your English shadowing.
You are doing a fantastic job mastering this complex material. Understanding these specific mechanisms gives you a massive advantage in the global agricultural industry.
Let's do a quick recap to solidify your practice. I'm going to clearly repeat the 10 vocabulary words we learned today.
Take a breath and shadow these terms one last time with us.
Immunosuppression,
Aplastic anemia,
horizontal transmission,
vertical transmission,
subclinical infection,
feed conversion ratio,
maternally derived antibodies,
live attenuated vaccine,
mass vaccination,
seroconversion.
excellent review.
Keep practicing those terms.
Thank you for joining us on this deep dive. Keep practicing your poultry science vocabulary, keep shadowing, and we will catch you next time as we explore more fascinating topics.